This video will be the first of many to come in Blackout Mathematics instructional course for calculus. We welcome you to the first episode, Introduction to Calculus. To understand calculus, we must first understand why it was made. And to understand why it was made, we must understand the problem that caused it. Calculus was developed to address complex problems in mathematics and science related to change and motion. Its creation was driven by the need to understand and describe how quantities vary and accumulate, such as how objects move over time or how areas and volumes are calculated. By providing tools for calculating rates of change, differentiation, and the accumulation of quantities, integration, calculus enabled more precise modeling and problem-solving in fields ranging from physics and engineering to economics and biology. That sounds like a lot. Let's consider the following example to help you understand what was just said. Imagine you're tracking a car's speed as it moves along a road. Calculus helps you understand how the car's speed changes over time. For instance, if you have a formula that describes the car's position over time, calculus allows you to find the car's instantaneous speed at any moment by differentiating the position function. Conversely, if you know the car's speed as a function of time, calculus lets you determine the total distance traveled by integrating the speed function over a given time period. This ability to analyze and calculate change is fundamental in understanding real-world motion and accumulation. So far, you may have noticed that we have talked about two very important sounding operations, differentiation and integration. Differentiation is a fundamental concept in calculus that involves finding the derivative of a function. The derivative measures how a function's output value changes as its input value changes. In simpler terms, it represents the rate of change or the slope of the function at any given point. For example, if you have a function that describes the position of a car over time, the derivative of the function gives you the car's speed at any specific moment. Differentiation is crucial for analyzing and understanding how quantities vary with respect to each other. Integration is another core concept in calculus, essentially the reverse process of differentiation. It involves finding the integral of a function, which represents the accumulation of quantities over a certain range. For instance, if you have a function that describes the speed of a car over time, integrating this function gives you the total distance traveled by the car during that time period. Integration is used to calculate areas under curves, volumes of solids, and other accumulated quantities, making it crucial for solving problems involving total accumulation or summing up small changes over an interval. Join us, Blackout Mathematics, in our journey to spread knowledge about one of humanity's greatest inventions, calculus.